But in order to find the volume of any prism or cylinder, instead of using this customized one, we can just use the area of the base times the height. So what I'd like to ask you to do is this. You're going to find the base. You're going to find the height that we're talking about. And then you're going to do the formula, the volume equals base times height. When I'm finding the base, what I'm looking for is the two-dimensional area, right? So this B, capital B, stands for the area of this shape. In this case, what kind of shape is that? Rectangle. And how do we find the area of a rectangle? Length times width, right? So I would do 9 times 17, which is 153. And that's the first part of my formula. It's saying find that base, which I just found is 153, times the height. What does this height refer to? Like some people said, this is base times height or length times width. So how do I know what this height is? Well, it's the gap between the two bases. It's the double stuff filling in an Oreo, right? It's how thick is this gap between them. So in this case, it's 24. So I'd multiply that base, whatever this one is, 153, times 24, and that would get me a total of 3,672. And what are my units going to be if these lengths were in centimeters? Almost. Centimeters cubed, because now we're talking volume. This isn't square units, this is cubic units. I encourage you to use this formula of base times height because it works for all these shapes. So let's move down to number 4. What's the base? What shape is it? Triangle, good. Remember that we're looking at all the sides of faces, and if they're not rectangles, or at least parallelograms, then they have to be the base. Anything that's not a quadrilateral must be the base. So in this case, it would have to be the triangle. And when I'm looking for that big B, that's what I'm looking for, is the area of that base shape. So what is the formula for the area of a triangle? Yeah, 1/2 base times height. And I know it gets confusing because we've got this purple H for height and this red H for height and this big B for base and this little b for base, and that gets all confusing. But again, this first thing we're looking for, the capital B, is just this two-dimensional figure. So when I'm looking for the base and the height, I'm looking for something that has to do with this two-dimensional figure, this base of 12 times its associated height, because it makes a right angle. So 1/2 of 12 times 7.3, which is 43.8. What's the prism's height? Good, 5. It's the double stuff, right? If this is one of my bases and this is the other base, it's how far apart are they? And then my volume says I'm going to take whatever my base area is, I'm going to multiply it times the prism's height, and that's going to give me my volume. So I'm going to take 43.8 times 5, and that's going to give me 219, what kind of units? Feet cubed, good. How's it feeling so far? 5, totally doable. 3, somewhat doable. 1, avoidable. Okay, thank you for putting your hands up, those that did. All right, what about number 6 here? It's still a prism, so my formula is still going to be the same. I want a B, I want an H, and that'll be enough to find my volume, which will be B times H. So that's my free starting point. In order to find the area of the base, first I have to identify what the base is. What kind of base is it? Good, trapezoid. It's this base here, because it's the only one that's not a quadrilateral that is a parallelogram. Remember, if they're parallelograms, excuse me, all faces have to be parallelograms. So if it's not a face, it's not a parallelogram, it can't be a face. So now we have to remember the formula for the area of a trapezoid. Do you know this formula? You might have memorized it. You might remember that there is one, but you don't memorize it. Hopefully you're not in the position where you say it's just base times height, because that would be flawed understanding. This is the one that's 1/2 the height times B1 plus B2. And if you've forgotten that, you'll remember that on the first day of this unit, I gave you this sheet with a bunch of formulas, right? All these area formulas that you're going to be using. So in this case, I would be doing 1/2. All right, now comes the challenge. All these H's and B's. What am I going to use for this H? 17.9, good. Because it's the height of the two-dimensional, the flat subject. This whole thing is all about the base. And then what are my two bases that are going to add together? 14. Good, 36. And when I plug this whole mess into my calculator, I end up with 447.5. What's my H? My height. Well, we used 17.9 before, but for this one, we want to do the double stuff, right? What's the gap between the bases? So that would be the 25. Instead of this? You can. But the trick is when you're finding area, it has to be what's perpendicular to the base you're using. And so this is a base times this perpendicular height. And then this is a base times this perpendicular height. I know it's confusing, but there's logic behind it. So this comes out to be 11187.5. And what are my units? Good, meters cubed. There's only one other application of this that's specific, which is when it's a cylinder. And again, they're trying to show us this new formula, like, oh, look, a new formula, pi r squared h. But you guys know, what is pi r squared? It's the area of the base, isn't it? So really, they're presenting it as a new formula, and you can use it that way if you want, but it's really still V equals B times H. It's the base times the height. So I recommend we continue for all this page, both sides, to use the same formulas. We want our B, we want our H, and their volume is the product of those. But in this case, my B is something unique. What is my B in this case? It's a circle. So how do I find the area of a circle? Pi times 18 squared, or 324 pi. I'm going to leave it in that precise form for now, rather than carrying a bunch of extra decimals. What's my double stuff? 15, right? The gap between the two cookies. So this is going to be 324 pi times 15, which gets us 4860 pi. But let's get a decimal approximation of that using the pi button on our calculator to ensure precision. 15,268.14 watts. Good, inches cubed. All right, that's it for today's instruction. You are going to be, hold on 1 second.